Hi, hello, வணக்கம் and welcome. இது உங்கள் the first step academy learn and grow educational medium. Today in this video we are going to discuss the answer for the book back question number 9 in unit 6 optics. Let's go to the video. The question: an air bubble in glass slab of refractive index 1.5 near normal incidence is 5 centimeter deep when viewed from one surface and 3 centimeter deep when viewed from the other or opposite surface. The thickness of the slab is given options: option A 8 centimeter, option B 10 centimeter, option C 12 centimeter, option D 16 centimeter. So first we'll imagine the question exactly. So this is the pictorial explanation for this question. So look at this image where there is an air bubble in the glass slab. Look at, there may be a air bubble present at O here in the glass slab, where the glass possesses the refractive index of 1.5. When we are looking from one side, probably this side, I will represent. When we are looking from one side, it look like 5 centimeter deep. Look at, when you are looking one side, it may look like 5 centimeter depth. But when we are looking from other side or the opposite side, then the deep or depth is 3 centimeter. So now they are asking us to calculate the thickness of the slab. This can be calculated by using the direct formula. What is the formula? The thickness of the slab T can be calculated by the sum of real depth from one side and the real depth from the other side or the opposite side. So that can be expressed T is equal to D plus D dash. So by finding the real depth from one side and the real depth from the opposite side, by adding these two values, we can find the thickness of the slab. So now we'll find the real depth of both the side. So we know the refractive index can be expressed as a real depth divided by apparent depth with respect to the depth. So the refractive index can be explained with respect to the depth as refractive index is equal to real depth divided by apparent depth. Look at the question. They have given a refractive index and they have given a apparent depth from one side as well as the opposite side. So I'm going to find two sides real depth and I'm substituting over here and I can calculate the thickness of the slab. So refractive index is equal to real depth divided by apparent depth. Now I need to find the real depth. What I have to do, I have to bring this apparent depth to other side. So what we will get? So the real depth is equal to refractive index into apparent depth. That's the formula that we got. So we know the value of refractive index they have given as 1.5 and we know the apparent depth of one side I have taken as 5 centimeter. So by multiplying these two, the real depth of one side I have taken as D. So 5 is the one depth and 1.5 is the refractive index. So 5 into 1.5 is 7.5 centimeter. Now the same way that we can calculate the real depth from the opposite side, that I have taken as D dash. So where the real depth from the opposite side is 3 centimeter. So the refractive index is 1.5. So the product of refractive index and the apparent depth, where 3 into 1.5 is equal to 4.5 centimeter. This I have taken as 3, where the D value I have taken as 2. Now substitute these 2 and 3 where in the equation 1. Substitute 2 and 3 in equation 1. T is equal to D plus D dash, where D is 7.5, where D dash is 4.5, D dash is 4.5. By substituting this, 7.5 plus 4.5 is equal to 12 centimeter. So the thickness of the slab is 12 centimeter that we obtained. So the answer for this question is yes. Option C is the answer for this question, 12 centimeter. So again I'm reading the question and answer. An air bubble in glass slab of refractive index 1.5 is 5 centimeter deep when viewed from one surface and 3 centimeter deep when viewed from the opposite face. The thickness of the slab is, the answer is option C, 12 centimeter is the right answer. Hope you understand how we arrived the answer for this question. If you like this video, kindly share and comment, and also subscribe the channel for getting more updates. Thank you for watching. We'll see you in the next video.